For this video lecture, I'm going to discuss adding two numbers using registers where I will save temporary results. I'm not going to use memory location, and I'm just going to use the add command for the actual arithmetic operations, and you will see a lot of logical operation and or XOR. Okay, so this is the code. So we have org 100. Since we are going to assemble a .com, an assumption here is we're just going to assemble uh, our code into a uh, com com file, executable file with com extension. Okay, so first is to get num. The idea of get num is you have to ensure that the input will be numbers only, and there will only be a maximum of 2 digits. So this is how it will look like, the subroutine. I use bx0, move cx1. I'm just initializing bx and cx. Just want to make sure that they don't have any uh, numbers there, because there are times that other previous program might have placed some numbers in your bx and cx. So just want to make sure that they will be they will contain zeros. So I'm going to use bx as my counter. The cx is where I'm going to save the data or the numbers that will be pressed by the users. So this is the get num, and then again, this is just a label, because when I was doing the program, I was using again one, again two, so I forgot to change the label. So we have again one here. So compare, if basically I'm going to compare bx if there are already two inputs. So since 0, we initialize it 0, so it's 0. So it will not be equals to 0. So it will proceed here. The first input, so it's not equals to 0. And then I'm going to say move EH by 08, interrupt 21H. So this is a keyboard input without display. So we will not display the keyboard input first. We have to make sure that whatever will be displayed are only numbers. So then we will compare what has been pressed, because for this interrupt 21 function called 08, whatever will be pressed will be placed on AL. The ASCII code of whatever will be pressed will be placed on AL. So the ASCII code for entry key is 0D. So we are going to watch out if it's an enter key. It means that the user has an option to input one number or no number at all. If you're going to press enter, the subroutine will already end. Or if he's going to input only one number and then enter, then the subroutine will also end. Or if he will input two numbers, the subroutine will force it to end because of this. And I've already mentioned this, only numbers will be allowed to be displayed and will be allowed to be saved in our register. So this is the part here later. So I'm going to this is my sample, so I'm going to use later on. Okay, let's put some. Okay, so to continue, oops, sorry, I have to put this so that I can discuss this. Next is I put the shift left CX. So shift left is going to the left. So since there will be two numbers that we're going to put in the register, so and a number will be in the, whatever will be pressed will be in ASCII code, and this ASCII code is 8 bits in length. So I can save the two numbers using only one register. At least for this subroutine, I'm going to save the number in CX. So assuming that I press, the first number I press is 3. So on the first run, the CL will contain 33. But on the second number, if I press 9 on the second number, it will become 39. So to save these two numbers in the register, I have to do this. Shift left 32. So no problem for the first number, but the second number has to be saved on the CL, so that you will properly place all this number in the tens place and the ones place. Then this one, compare AL to 0. This is the trapping part. So I'm going to trap numbers only. So if what has been inputted are not numbers, so we're going to ask again the user for an input until such time is either he inputted two numbers or he input enter key. Then if it's a number, this part here, it will be displayed, but if it's not a number, it will go back here again one here, that part. Okay, so assuming that numbers were inputted, so it will go here, and then I'm going to move AL to CL. So it will be the AL contains the what has been inputted in the original input routine, which is this one. This is the input. So the AL will be the key press will be saved in AL. And then what I did is I saved that AL and I put it in DL CL. Then I add BX by 1 because we use BX to count how many keyboard has been pressed. Then jump again. So the whole subroutine, we just have to make sure that what has been inputted are maximum of 2 numbers. Basically, that's what it does. It's called get num. So after I call get num, so I move the CX, which contains the first set of number, to SI. Okay, SI is a special purpose register, but you can use this. The CX, AX, BX, all those with X's are general purpose registers, and general purpose registers have two parts. You have the higher part and the lower part. Okay, so I save it in another register because I've been using CX. So if you're not going to save it, then you're going to lose your data. Then I call next line. This is a code that I have been using. Next line looks like this. So next line. Yeah. So basically, next line is just I use this so that your the next input will be placed on the next line. Just like this. If this is your first input, the next line will go here. So there are two ASCII codes that you have to display using interrupt21 function called 02. You have 0D and you have the 0A. This is carriage return. The 0A, 0D is enter key. Enter. Okay. That's the next line. And then I will call again. I'm just reusing the code, so I call again get number for the second set of number, and then I save the second number in DI. As you can see, twice CX, because this subroutine, in this subroutine, the numbers will be saved in CX. So same in this subroutine, the numbers still are saved in CX. And if I did not do this, what will happen now? I did not do this. The CX, after executing this subroutine, the CX will now be, the value of CX will now be changed to the second number. So that's why it's important that you have to keep track of your data and save them somewhere where they can be preserved. Then I call next line twice. Actually can only use one, but I use twice so that you can easily distinguish what are inputs and what will be the output. You'll see this in your emulator. Unfortunately, I cannot show this in an emulator because this particular laptop does not have an emulator. I'm using another laptop when I was doing all the other sample programs. Next is, uh, we know that your numbers are now in SI and DI. So, since the numbers that had been saved there are still in ASCII form, we have to strip it into a number because we're going to add them later on. So, example, in my example earlier, we said that if your number is 39, when you press 3 and 9, what has been saved will be 33 and 39. So you have to remove the extra 3 there. So you can do it this way, or we can just subtract SI by 30, subtract DI by 30. So you remove those numbers and you retain only the values in the values in ones and tens places. Next is I'm going to move SI to AX, DI to BX. So now I'm free to use since I've been using the different registers when I'm doing the subroutine. So now I'm going to reuse those general purpose registers for uh, adding the numbers or manipulating the data now. So here, first is I copy the value of SI to AX and DI to BX. Then I'm going to call add num. Add num, basically what it does is this, will add numbers. So we know that the AX and BX now contains our number. Let's see, let's double check. Yeah. So AX contains the first number, BX contains the second number. Okay, so the significant number here is in AL, the least significant or the ones. The tens are in the AH. So same as BX, for the second number, the significant number which is placed on BH, the least significant which is the ones place is in BL. Okay. So you have to remember that. And then we go to add num. Let's look at the add num. So this is how it looks. So I make use of CX. So basically I just want to clear the value of CX now. So this is also like this. So just want to make it look fancy. X or CX. So if you're going to XOR the same number with a number with its the same number, then you get 0. So this is basically same as this one. Move CX by 0. Then I add the numbers, the BL, because they are now in the BL. These are the ones place. Then I'm going to compare the result. If the result is 0A, because when you use the this add command, it will treat the value as hex. So they will be added as hex number, not as decimal number. So 9 plus 9, example, that will give me 12H. So if I want to get the 18 value, I have to add plus 6, so that I am going to have 18. And this is what I did here. This one here. Add BL by 6. So the result is placed in BL. I'm going to add AL plus BL plus AL, and the result is in BL. Then I'm going to compare if the result is more than 10, because I have no problem adding numbers less than 10, like 1 plus 1. The result of that is 2. So 2 in hex, the result will still be the same in decimal. I will only have some problem if my result is already more than 9, starting 10. So if it's below, I will just proceed. So this subroutine will already be finished. But if it's more than 9, then I have to add CL by 1, and then I'm going to add BL by 6, and then I'm going to add BL by 0F. Basically, I just remove the last part, just retaining. Here, if my example is 18, what I'm doing here is I'm just removing BL is equals to 8 or 08, if you want to be more precise. This is my result, 9 plus 9. Just placing it here. But the 1 I place in CL, assuming that there is a carry. Okay, so let's go back for the first number, for the ones. So this ones. Then I add I move BL, which is the result, because I add AL plus BL there below. I put it in DL. Okay? So but you have to remember that I still have the CL there. The CL is the supposedly the carry. Now I'm going to proceed to add tens. So same as what I did above, since the original value, the original inputs are in SI and DI, has been saved there. We secured it. So same thing, I also put it in AX and BX. And then I move AH to AL. And then I add BH by 1. And I put BH to BL. You might ask, why do I have to do all these things? This one is pretty much explainable, because the assumption here, the CX supposedly contains the carry. If it does not contain any carry, then it's 0. But if it contains carry, so I have to add it to the BH. Since we're now adding the tens, and they are in the BH and AH. But I have to transfer them again in the AL, because I am reusing a subroutine that only adds the AL and BL in my addNum. The above when I add the ones, I have no problem here. I'm just going to add AL and BL. But since I'm going to reuse the subroutine addNum and the addNum, I'm adding the AL and BL. So I have to transfer the AH and BH to AL and BL. Plus the carry, I have to add that already in the BH before I transfer it to BL. Then I call again addNum. So the result is still in BL, same here. The result there in addNum, the final result, let's look at again at addNum. It's in BL. The result is in BL, this one. From here, the result is in BL. So, twice I transferred BL. The first one, when I add once, I transfer it in the DL. And when I added again, I transfer it again in DH. So now, the result for ones location, the ones location, and the tens location, the ones location is in DL, the tens location in DH. Okay? That's the result. But wait, there is more. There is no problem if your result is, say, you're going to add 45. Wait, let's put here. Let's say you're going to add 45 plus 46. That will give me 91, right? So no problem because the carry here is here. I already added in BH. But if the result will be 3 digits, so I have to compare again if there is a carry in my next in my second when I added the tens place. So I said there another carry. We'll go to that later on. Assuming that the CX that the next time I call addNum, the result is only 91. So there is no carry. So this one will be ignored because there is the CX here will be 0. So what I did is I add DX by 30. So by this time, my DL, my DH contains the tens result and my DL contains the ones result. So what I did is, since I'm going to display them later on as a result, and to display them, I have to convert them back into ASCII code. So I have to add 30 for the result of ones and 30 for the result of the tens. That's what I did here. Then I have to save BL to CH. You will see this later on why I have to do that. Then the DL contains the ones, so I have to save it in the CH. Then I'm going to display first the tens, this one, as a result. So display tens, I have to call this function. Basically what it does is display one character, which is what is inside your DL. So your DL, the original content of DL is the result here, the ones. So I have to replace it with the DH since we have to display first the tens. And then since I was using the DL here, when I invoke this one, so I have to now display the result for the ones. That's why if your result is 91, the first one that will be displayed, because your display will be from left to right, will be the more significant number, which is in the DH. So assuming that will be displayed 9, then after that I have to save the DL to CH. Why did I do that? Because I'm using interrupt21 function called 02, and the DL value is changing. I've changed it. So now the second digit, I have to put the CH now in DL, whatever the value there. In our example, that is 1. And after that, I'll now jump to exit. That is if my final answer is only 2 digit. But if it's not 2 digit, there is one more carry, then I have to go to another number, and you will see what happens. I just copy the whole thing. Basically, the whole thing, I just copy this thing. But the difference is, first I have to display this one. I just added this one. All the rest is the same. So there is a carry 1, so I have to put 1 there first in the most significant digit. This is the hundreds place. And then the result for the tens place will be displayed same as the above, this one. And then the result for the ones place same as the above, this one. So that's the magic. So this is the same as this one here. There are only the result is only 2 digit, but I just added this one. The result is 3 digits. Yeah. So then of course exit. Exit is this one is keyboard input before it exit. It's just like a pause, so that we will see. Basically, you can just remove it. I just put it there so that when you use the emulator, it will before it will exit, it will wait for a keyboard input. Any keyboard input, it will exit. So that's it. That's how you add uh, 2 digits, maximum of 2 digits each for each input. So I hope you understood. We'll have more example on this. I'm going to post some more videos. Next time I'm going to have an example wherein I'll use a memory location instead of juggling all this data in the different uh, registers. So thank you for listening, and I hope you learned something from this video.